It's like how non-negative, because like it gives an example of like the person like said that was trying to switch subjects inside, but it was supposed to be 25 so they were like they had a 12% error rate because they were like reading them all. So it shows like true value or the true solution of the problem, and the position is like how close you get to
Wait, this is outreach.
or it's like because like the more zeros there are, the more you know the answer is right, the more precise. Yeah.
What is it?
How many percent? So what the more zeros, I don't know about how much numbers used. I don't know that either.
I don't know. I only remember like the same. Wait, so is this piece?
That's why I'm doing Yeah, you should have a textbook in front of you if you need to reference anything outside of your notes too. I have no textbook. Yes. He's getting them for you right now. Yep. Oh, okay. Jacob, I think all three of those belong up here. The four that I started right now, I'm going to do Raise your hand if you're on question 5. Are you in question 5? Raise your hand if you're in question 9. And you're like, what the heck is absolute temperature? Okay. Do you mind if I pause and we kind of start going to the beginning ones? Make sure to pause where we are in thought. Okay. So the question 1 and 2, we went over for warm-up already. I think we're fine. How do you calculate percent error? Lael, tell me how you calculate.
The absolute value of the experiment value minus the accepted value.
Okay.
Over the accepted value.
Okay. Times 100. So to get percent error, it's just the difference, so the difference means subtraction, right, between the two values, one of which you found in your experiment, one of which you probably found the actual value to, like online, in a textbook, on the periodic table. Those are like published values. It doesn't matter if it's A minus E or E minus A. It's absolute value, right? So it doesn't matter which way you subtract. It's going to be the difference, and you always divide it by the actual value or accepted value. So that terminology we'll use occasionally. What's more to that question? Oh, we explained that. Good. Okay, so why is there a need for sig figs in calculations? What are the rules of significant figures in addition and subtraction, multiplication, and division? I heard some people go, I'm going to skip that one. But I think you can maybe tell me what you learned in sig figs, because that's one of the hardest things for people to kind of grasp their head around. Like, why can't I record more digits? Why do I have to record this exact number? Miles, what do you think of sig fig? What's the need for it in calculations?
I think, well, I'm not sure, but I think it's so we know how accurate the numbers that we're using is.
Right. So what if you have this ruler? I don't have yardstick, meter stick. I didn't mean yardstick. I meter stick. Okay. Metric system. If I had this and I look on the other side, you guys can see the metric systems here, right? We've got meters and centimeters and millimeters. Well, there's tons and tons and tons and tons and tons of graduations there for the lines. That's going to give me this tool. It's really good. It's going to give me a pretty accurate value, so I can measure the length of my marker down to like, gosh, let's see here. It's like 14.4 centimeters, but then I can go one more digit. I can have the power to estimate one. So 14.01, 14.02. Somebody else's last digit might be different. But if I had a ruler with no graduations here, the most accurate I could get would be like, it's over 10. You know, I wouldn't know a whole lot if all these little lines were in here. So our tools that we have make us accurate or less accurate. So no one wants to lie about how accurate they are, because if the ruler or the tool we're using is not very graduated or not specific, we can't lie and go, this thing's 14.000000001 centimeters, because we don't know that much about it. So it's to limit the lies in our measurement, so to limit the or to describe appropriately the accuracy of measurement. So we don't have like say we're overly confident in how accurate the value is. Now the rules for addition and subtraction, turn on the other side of the sheet where the notes are. You see in the little box area the rules there? You see those rules? Put a star next to them. We're going to be using those later on in just a couple minutes, so there's no need to rewrite them. I've written them out for you. So we will go over that in a second. What are the base units in the SI system? Why do we have these standard base units? We went over a couple of them already. What are some of the other base units in the SI system? Richie, tell me one. So we did meter, gram, and what else do we do? Oh, Kelvin, thank you. What else is there? Milliliters, right? So you can say milliliters or liters. Either one is appropriate. Jacob, tell me another. Amperes, right? And that's something we do a lot in AP chemistry. Little teeny bit here. Yeah, Nick.
It wasn't on here, but the joule for
joules, yes. Okay, so I'm going to go over that as a warm-up later on in our chemistry lab here. But joules is labeled as J, just a capital J, and joules is a unit of energy that we talk about in chemistry. Okay, so we'll go over why we have these. We need some consistency. There was a big catastrophe with, I think it was a Russian rocket or a U.S. rocket. Somebody didn't convert it to the metric system, and somebody else assumed they had in measurement, and there wasn't enough fuel to go someplace where they were going. So like things like that. There are catastrophes that can happen if people don't have consistent measurement. And then absolute temperature scale. Who does know what that is without me talking about it first? Nick, go for it.
Is that the Kelvin scale?
It is the Kelvin scale. So I referenced it briefly, but absolute temperature scale is the Kelvin scale. And then related to that, absolute temperature scale is going to give us the absolute amount of energy within a piece of matter or substance. So it's going to tell us about energy of that matter. So absolute zero is a special part of that numerical absolute temperature scale, because at absolute zero, it's a theoretical value, 0 Kelvin, not okay, 0 Kelvin, okay? So 0 Kelvin is what the absolute temperature scale is, the very, very, very bottom of it. And at that point, all movement stops, okay? That means the little particles that your body's made of, okay, you know, we're just a bunch of chemicals, right? And every single chemical in your body right now is vibrating. And it's vibrating with relation to the temperature of your body. So, what's 98 in Kelvin? What's 98 in Kelvin? What's Fahrenheit? Never mind, we don't convert from Fahrenheit. Let's say your bodies are 60 degrees Kelvin. That would be really cold, right? But no matter what, your particles in your body are still moving. Technically, if the particles in my body didn't repel the particles in your body, you know, because like obviously if I touch somebody, I'm not going to go straight through them. But if they didn't repel, we could just walk straight through each other. It's fast. It'd be really easy in the hallway getting to know their class. Like, he's going right through you guys. But our particles don't like to play well with each other, so they hinder each other and stop. But that's because they're particulate motion. If everything gets down to absolute zero, then we don't have any motion. None whatsoever. And that's when all movement stops. So we'll talk about that more later. And other than that, I don't want to do the rest of reading guide 3 because I think you guys gleaned a lot of it from our videos last night. And I'll tell you more as we go which ones I want you to do. I'm trying to limit the amount that you're doing at home. Deal? Okay. So let's go ahead and do the significant figure talk, because I think that this part dealing with measurement is going to be really helpful before we start moving on to actual calculations. So take about minutes right now. With a partner next to you, please talk that way. If you need to move, that's fine. But I want you guys to write on paper. Remember, these are helpful. They're really coming right now. Start at the very beginning. I talked about how significant figures and measures. Just jot down short ideas on your you write on the same paper you were writing on for warm-up. You write on the same paper you were writing yesterday. It doesn't matter to me. Start on question 1, and then you'll probably get through question 10. Question 1 through 10 right now.
Yeah, you can tell that it's above zero. So you can only start from zero. No, like we're supposed to be measuring now. And it's asking us how long what is considered that it is. But only that for the certificate above zero and less than 10. Okay. Well, no. What sign is that? Yeah, 0 to 10. Can't be accurate. Like something gets for my Elizabeth here. Okay. So moving on down, ruler 1 is not very useful, but a measurement can be estimated, discussing a group how they may have divided up the ruler by eye. So basically that estimation, everybody has to do an estimation. This one, they just had to make the estimation the very first number. Most of the time the estimation is going to be our tail end, where you're like, oh, it's between the two dashes. Maybe it's halfway, maybe it's 3/4 of the way, you have to make an estimation. But let's look at the next ruler. A bit better, right? So we are certain of every integer between 0 and 10. So it's a much better ruler. So because there's more graduations or markings on it, what do you see over here? It's more of a constant measurement. There's more agreement that it's at least what, guys? It's at least 3 centimeters. And then some people recorded with 1 decimal, some recorded with no decimals, some recorded with 2 decimals. Well, we're going to talk about which of these are valid measurements in a second as well. But at least everybody's saying it's a 3, and then from there, they estimated a digit after that. That estimated digit is still a significant figure. You will record those. I think we did these. Okay, so down to question 7. There will always be uncertainty in measurement. This causes variation in measurement, even if people are using the same exact instrument, meaning like a ruler. Compare the variation in measurements of the 6 people. Which ruler resulted in greater variation? So of the rulers 1 and 2, which rulers resulted in greater variation? Greater variation, so meaning less consistency. Ruler 1, because there wasn't enough information there. But look at ruler C, it's beautiful. Look at it, it's got so many low graduations on it. So how does that reflect in the measurements taken by these students? So now everybody's like, oh, I at least can see it's 3 point something.
So basically, everybody has a decimal number after the decimal. Some have another one, and then some have a third one or fourth number. Some of these are invalid. So like Emily here, she says 3.215. Come on, homegirl. Like, how are you getting that accurate? There's nothing here. You see 3.2. And then she's going 1.5 after that. Like, there's not enough little lines to give me that. She can maybe say 3.25 or 3.21, but the extra estimated one is not appropriate. So the best that we can do here is Susan, Jonah, and Maya. Those three there, except Susan didn't put centimeters. We'll give it to her though. We do like these because 3.2 is like, I'm certain of that. And then the last one is the estimated digit. And everybody has their own opinion on the estimated digit. This one's not enough. Mark didn't give me that little extra estimated digit. And these two people went too far, meaning they're lying about how accurate they are. Do you see what we're talking about here? So it's
Sometimes hard to wrap your head around, like, what is a sig fig? But it is based on your units of measurement. Okay,
last one we're going to do. So this is the valid and invalid one. Looking at ruler A, valid measurements, you can see only have how many sig figs? How many sig figs are in these numbers here? Actually, since you see the number there, there's no decimal, I know, but so the decimal is absent, so you're going to start counting from the Atlantic. So the first non-zero digit is a 3 and a 2. So that's one sig fig in both of these. And that's because there's no graduations, other than the 2 on the ends here. So we can only estimate one digit. So these are all invalid because they are trying too hard. They're trying to really get accurate, but there's nothing there to help them. So these are lies. These are invalid. Ruler B, what can we be certain of? How big is it? 3. That's certain. And then what's your uncertain digit? Whatever you say, right? So point something. 0.2, 0.1, 0.3, those are all valid because it's up to your opinion. These are invalid because we know it's 3, honey. Give me something more, 3 point something, because you have to have the estimated digit. This is too accurate, right? So basically they're lying to say, I knew exactly it's 3.25, but they can't be certain that last digit's true. Same thing here. So these are invalid because they're recording too many. You can only record what you know and then in one estimated one. Yeah. So 3.2 and 3.20 are different in their number of sig figs. So that 3.20 is saying that you're absolutely sure it's 3.20, whereas 3.2, you're like, I know it's 3 point something, but that 2 for me is maybe it's whatever it said, 3.1. It's not 3.2. So it's basically you telling how accurate you think all those numbers are. I know it seems the same, but it's actually not in chemistry. And then the last one, the most accurate you can get is 3.2, because that's where the measurement is here. And then your flexibility on the estimation is the final part. So 3.21, 3.22, 3.3, or 3.20, but these people have too many or too few. So always look at trying to give me a digit 1 right after the one you know. So that's called your estimated digit.
and we'll be working with that in the lab.
So who's kind of feeling a little bit like you're 50% sure on how to do measurements? Okay, we'll keep on working, but it's gonna be some practice.
Okay, we'll do our lab with that. All right, switching modes. We're gonna go talk about some of the stuff you did last night on homework, and then also do calculations. All right, so who has a calculator?
Awesome. Okay, if you don't have a calculator, I'll get you one in a second, or you can share with a peer. So pull out your stuff from last night. I'm gonna go through a couple of the examples at the end. Here, on the U track. So have these out because you should have attempted these last night.
And so I do expect that you're
Going through, trying, and then asking questions the next day in class. So I'm going to start off by just going through how many sig figs are in each of these. So eyes up here, check yourself as we go. I'm just going to do a quick explanation for about 3 of them. So I see there is no decimals present, so it's absent, right? start counting the number of digits from the Atlantic. The Atlantic is over here. So when you start counting the first non-zero digit, which is it this? No. So you skip that when you start counting at the 4, and once you stop, you don't stop, right? Pringles. So 4, 0, 0, and 3, that's 4 sig figs. That last one is an estimated digit here. B, 1,500 milligrams. Okay? How many sig figs did you guys say? I heard it. 2. Good. Absent. The decimal is absent. Start from the Atlantic. Skip, skip. Those 2 right there are 2 sig figs. C, 10,000 liters. How many sig figs? 1. Good. 1. The decimal is absent. Start from the Atlantic. Skip, 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 skip. The first one you're starting to count at is that 1, and that's it. 1 sig fig. Let's go to. Oh, I didn't mean to go B. This is D. This is G. I like to kind of mix it up, guys. Okay, going back up here to B. B, 0.0008 meters. How many sig figs did you guys say? 1. Okay, so basically what I'm hearing people saying is 1 because they see the decimals present. They start from the Pacific, which is the left-hand side. And once you start seeing a non-zero digit, that's when you start counting. So skip, 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 count. 1 sig fig. But that's a pretty good ruler or whatever they're using, or meter stick, because it's got a lot of placeholders. Let's go down to, let's go ahead and just, you guys shout out the rest of these, okay? I got all those. Oh, actually, no, we didn't do this one. Did we do this one? No. How many sig figs in J? 3 sig figs, good. E? 2, because that 0 is, whenever you see the decimal's absent, you don't start with the 0, you start with the 4 and the 6. How many here? 4. K? 2. The decimal's present, start from Pacific, skip, 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 5 and 6. Next, did we do that one? No, okay, C? 5. There are 5 there because the decimal is present, you start from the Pacific, and that 2 is your first non-zero digit. So you count the 2, the 0, the 9, the 0, and the 0. Once you start, you don't stop counting. So there are 5 there. F, 4, good. Because that decimal is present, start from the Pacific, count 1, 2, 3, 4, all the way across. Next. So we're saying 4 because we said decimal is present, start from the Pacific, skip, skip, because those are 2 first of the non-zero digits, and then count the rest. So 5200, that's 4 sig figs. Last one? 2. Right. Who feels like they got 90% of those? All right, so I got a couple people want to keep working on it. So I'm going to keep repeating those instructions and kind of walking through the steps so that we're all kind of getting on the same page. All right, so here we are on the rounding, and I think this is like number 5 on your problem set 3A. And some of you may have attempted it, but I'm going to walk through the example first. This is on the paper that you were just working from on the back side. So on the back side of the reading guide. Do you see it? This rounding example is on the one I'm doing in lecture. Let me see here. It's right above the sig fig box that would have instructions for adding and subtracting. Give me a thumbs up when you find it. Okay, so I try to print these things so you don't have to write everything out in terms of the numbers and stuff, because it's easy to mess up a number. Then you'll do your other stuff on problem set 3A. Okay, so whenever you're rounding, so let's say we have some number that we've calculated, either adding, multiplication, subtraction, division, and at the very end, you don't want to lie about your measurement. You want to lie about your calculation, so you have to round a number to the appropriate number of sig figs. Well, how do you round? I know we all know how to round. Sometimes you have to round up, sometimes you have to round down. But when sig figs come into play, your final answer can't have more than that many sig figs, right? So this one has how many sig figs in it as a whole? There are 9. There are 9 digits, 9 sig figs there, right? That's apparently a really accurate number. But what if you were only supposed to be able to measure 3 sig figs accurately? Well, that means you have to round to 3 sig figs. So the instructions here, I don't know if I have these on your paper. Do I? No. Okay. If you want to jot down these, I'm going to use those as we roll. Always start counting sig figs at the left of the number that you have to round. So always start at the left is probably the most important thing to write there. and replace non-zero digits with zeros after the correct number of sig figs is obtained. And the reason you're rounding to a certain number is because you don't want to be lying about your measurement, and you replace the non-zero digits with zeros because those zeros will not play into your actual sig fig count. So we're going to round it to the appropriate number. And I'm going to start with 3 because that's what I just said. 3 sig figs. So on this, we will never change the size or the scale of the number. In the end, every single time we make our answer final, it's still going to be about 50,000, right? You're not going to round it to 5, because 5 and 50,000, that's totally different. You're not going to round it to 50. You're not going to round it to 560. Like, you're not going to round it to a number that's significantly different than what this number is. This number is 50, almost 60,000. So we can't round, so it's totally different. So here we go. Because I'm following these instructions, I start from the left, and I'm going to go, I need 3 sig figs. 1, 2, 3. Those are the 3 I need. I write them down. 5, 0, 6. Okay? Can I leave it like that? No, because that's 506. That's not even close to 50,000. That's 100% off, right? So the rest of these digits that are placeholders are 0, 0. Yes, they are the same as the 0, 0 here. But if I had like a 1 and a 2 here, 50,612, I would still record those as zeros because at this point, rounding means I still need the size to be approximately the same, so these are placeholders. So if you were to make this your final answer, you're in good shape because how many sig figs are in this final answer? There are 3. Decimal is absent. You see decimal there? So absent starts with the Atlantic. This side, skip, skip, 1, 2, 3. There are 3 sig figs there. And the number is still about 50,000, so I'm still in good shape. Now let's round to, let's go back to do the first one. 1 sig fig here. If I only want 1 sig fig, what's the first number I record? The 5. All right, I can't leave it like 5 because 5 is not even close to 50,000. So what do I want to do with the rest of it? Make the rest of them zeros. Now the rest of them, how many zeros here? 4. There you go. Because the rest of these cannot round up or down because then I'm going to have a problem with the number of sig figs in the final answer. 1 sig fig in that final answer, we're doing good. Let's round to 2 sig figs. What are the first 2 numbers I record? So right now we're saying 5 and 0 because we're reading a 5 and 0 right here. 5 and 0. But what's the next number after the 0? A 6. Generally when we're rounding, we have to consider the next number, right? Does that 6 influence that 0? It does. It rounds it up. So we can't put 5, 0. We have to put 5, 1. Okay. So now, what do I do with the rest? 0, 0, 0. Say again? You want me to review this one?
Yeah.
Okay, let me
I'm still a little iffy on the subject
of rounding or sig figs, you think?
rounding.
Rounding. So it's really the same rounding as I've always have done. If I said, take this number, and just round it, you guys would probably go start over here and go, oh, let me round up. 5's going to round the 7 up. But I'm telling us to round in the middle of the number. And the rest of those placeholders, the rest of those digits, they're just going to be zeros. So I'm making this round in the middle because if I round, let's say I wanted to round right here. I have this 0 right here. What would you be looking at to round? The next 6, right? You'd be looking at this 6 and go, that 6 is going to affect the 0, and what would you do? You would make that 1. So you would record 5, 0, 6, 0, 0, 1, or 0.1. But I'm asking us to round further up, and so that's what's causing people to concern. You're like, you don't round in the middle of the number. No. But I'm going to have to practice with this a little bit more with you guys. Yeah.
Why do you use the 1?
Because if it's a number above 5, if the number after where you're interested, so if I'm interested in this number, I have to look at the next number to see if it's going to be rounding this first number up. If this following number is greater than 5, it rounds up. If the following number is less than 5, it stays where it is. And they say round down, but it's just going to stay what it is. So since that 6 is greater than 5,
it influences that, and we round up to 1. So I'm telling us right now to round to 2 sig figs, so we're rounding right here someplace, and that's why in this example, I look at the first 2 digits, and I look at the next one just in case, and that 6 is greater than 5, so it's going to cause that 0 to be rounded up to 1. Yes?
Are you still gonna round like from the left or from the right?
So I'm recording the number of sig figs by looking at the left numbers. So I'm recording 2 sig figs, and that's why initially we said 5, 0.
So you'll never do it from the right.
Correct. But I'm going to look at that tail end, which is on the right side. I'm going to look at it and make sure it doesn't round. In this case, it did round. So you always look at the last number that you're recording and see if the next number is going to affect it. And if it does, you do round. So I'm going to keep working through some examples, and I hope I can clarify some more. So if you were looking at this number, don't you see it's really close to 51,000? Yes. And so that's why our number is 51,000 when we round up. Yes.
So if it was lower than 6 or lower than 5, would it be the same number as rounding to 1?
Yes. And we'd have to record it in scientific notation to accomplish the 2 sig fig requirement. I'm going to get to an example like that in a second, okay? Let's go down to to sig fig. Let's go to the 4th one. Okay, so 4 sig figs is what we're looking at here. What are the first 4 numbers? 5060. Okay, and I can't leave it like that because that's not 50,000. So I see the next thing is a 0, so I could go ahead and put a 0 there, right? And now we're like, hey, yeah, it's 50,000-ish. How many sig figs are in this problem though, or in this answer? 3. There's only 3. My requirement was 4. This is where we employ scientific notation to meet the requirement of the number of sig figs. Can you write that in scientific notation? Shout it out. 5.0. Okay, I heard 5.06, and I heard times 10 to the 4th, because if we put the decimal there, I see that, right? But how many sig figs are here? How many are here? 3. So what do I need here? A 0. That's how I meet my sig figs.
You guys do that?
I'm still
Yes. Yes. Nurse Desi Philippines. Okay. All right. So the 5th one, guys, and this is the last one I'll do right now, because we're gonna do adding and subtracting today too. So let's do the 5th one. 5 sig figs. Ooh, that's really bad. 5 sig figs. So what did we record? 50600. Right, so that very last 0, that's the 5th sig fig. You look next and you're like, oh, it's a 0, we're cool, we're good. But how many sig figs are in the way I've written it here? How many are here? There's still only 3 because there's no decimal. So now you have to employ scientific notation. So 5.060. 0, 0. You actually need all of the numbers to make sure there are 5 sig figs there, times 10 to the 4th still. So it's just manipulating how we record our answers, so they are manipulated to appropriately represent the number of sig figs. And this is kind of the hard, like rounding I think is the hardest part. After you get sig figs, you're okay, and then you get around and you're like, wow, am I doing this? But this is going to make more sense when I start to use sig figs in measurement now. So if you have questions here, hold them, put a note to yourself, because I need you to ask them to me later. Read over these. They're on your paper and they're up here. Read them first and then I'll ask you a question. All right, what's the glaring difference between these two rules? Multiplying and dividing require what? Yes, you to count sig figs. So that's one big difference, because adding and subtraction requires you to count
decimals, things after the decimal point. So that's a little different, but if you remember, multiplying, dividing have the same system, and adding and subtracting have the same system. We're in a good place so far. But anytime let's say Jillian measures something that's got, I don't know, 5 sig figs in it, and then she's adding it to other Jillian's measurement only has 2 sig figs. Well, you're the weakest link because you only got 2 sig figs. That's not very accurate. Like me on the cross country team, I was the weakest link. Okay, overall, I controlled the final outcome. So overall, you control the final outcome because you have the least accurate number. And that's okay. The weakest link is going to control our final answer. So the lowest number of sig figs will control our final answer, and lowest number of decimal points will control our final answer. Basically, so we're not lying about our measurements yet again. Try to be honest in here, okay? So, and then my joke for the day. Know all the words about all about that base, but can't remember sig fig rules. Boom, boom. Okay. So let's look at these. These are on your sheet as well. Find them. Okay, calculator. And I'm going to pull mine out too. Calculator, calculator. All right, simply plug this in your calculator right here. Plug A in your calculator and tell me what your answer is. If you don't have one, use a friend's right now, and then I want to make sure we go through a couple, then I'll hand out calculators. And don't cut off your numbers, okay? Give me the whole slew of numbers afterwards. So what did you get, Kim? 0.87 and on, right? Okay. And if she were to say the units for me, she would say what? Grams per milliliter, right? All right, so that's like a really long number, but where do we stop? We need to go back to the original 2 measurements, which were this guy, and then tell me how many sig figs they have. How many sig figs are here? 5. There are 5 sig figs there. How many sig figs are here? 3 sig figs. Who's my weakest link? Weakest link, so lowest number of sig figs. So the 3 sig fig one, right? Okay, so 3 sig figs is what we record this as. How would you record this to 3 sig figs using rounding? Which ones count? 872. And you gotta just do a double check. Does the 0 influence the 2? No. Does the 0 influence it? No. Final answer, 0.872 grams per milliliter. See how we did rounding there? In action, like with the calculation? Yes.
So if the 0 was a 5, it'd be 873.
Yes, ma'am. If this 0 was a 5 or higher, it would be 873 there. Okay. All right. So that I went ahead and I accidentally told you count sig figs because it was a multiplication division problem. Let's go ahead and go to beef right here. Okay. Calculate it right now. And what'd you get, Chloe?
4900.
4900. No decimals, nothing crazy. What centimeters times centimeters? Centimeters squared. Good. So am I counting decimals or sig figs here, guys? Why? Right, because the rules for multiplication division, you count sig figs. So I'm counting, and I see how many in the first one. Good. I didn't hear anybody say 3. There are 2 sig figs there. This one? 2 sig figs. Final answer should have 2 sig figs. How many sig figs are here? 2. We're good. Sometimes it's a really quick check to make sure that you have the appropriate number of sig figs. And you get really good at just looking at a number like, I don't see decimal. 1, 2. That's it. All right, do C. Calculate. And 3, what you got? 42.78. What's the unit? Centimeters, right. All right, so sig figs or decimals? Why decimals? Because it's adding, subtracting. So you switch modes. Who's my weakest link in terms of decimals? How many decimals are here? 1. How many here? 2. How many here? 1. What rules? 1 decimal is what we should record. 1 decimal after, or one digit after the decimal. So here's my decimal, here's my 7. What do? Right. The 8 affects the 7, making it go rounding up to 42.8 centimeters. All right. Can you guys? Yes, Sam.
What do we do with the decimals then?
So when I say count decimals, I mean the digits after the decimal. So the decimal is still there, because this number, 42.78, should be approximately the same as the final answer, and the final answer being 42.8 is just a better version, a more accurate version of our calculation here. So we just count the number of digits after the decimal. Let's do one more for kicks and giggles. Let's do D. And remember your name? Person. Do you have a calculator? No. Did you do it in your head?
Kind of hoping I got it right.
I'm ready.
2,464.5.
All right, and then deciliters, right?
Yeah.
Okay, so if this is our kind of pseudo final answer, am I counting sig figs or decimals? Decimals again, because it's an addition subtraction problem. How many numbers after the decimal? 0. Okay, note 0. None of those. Or there's nothing after. Here? 2. Here? 1. Okay, so I need to record this with how many places after the decimal? 0. Nothing. Right, so now what do I need to do with this? I'm ready when you are. Right, so this 4 is going to be influenced because I can't have that 5 after the decimal. I have to round that up to 2,465 deciliters. So I'm glad you guys are getting a grasp of sig figs. Now you're getting rounding in context. Rounding by itself is like, why am I doing this? But in a calculation, I hope that this made some more sense to you. Well, you guys, don't worry about these unless you want extra practice. Go ahead and look at PS3A. If you need to pull up on your phone, do that. And then please work with a partner. And let's see if you knock that baby out. We have about 20 minutes left. I may be off on time a little bit, but start working on this until the bell rings, because I don't know if they're going to ring it late or early because of homeroom being a different time.
I already did all the calculations. I did not round any of these because I didn't know how to. What do you do with 2?
It's not that.
Oh wait, it's not. Close enough. Number 3? Or that was third.
Okay. I already said remain 4 3 2. I did 1. So just write 4 3 2. I did not even. You want it to be here, but you're seeing that. Oh, okay.
Let me show everybody on the board. You're not the only one. Please ask each other questions. I'm showing one thing on the board because website stuff. The more button. Yeah, I tried to demonstrate that daily because it's sometimes hard for people to find. When you go to Honors Chem documents, Unit 1 looks like there's 2 things in it. You know that's wrong. You gotta see more. More. And you can see the plethora of resources. And then do you know where it is now? Why is this being like this? It says right here, Unit 1 student packet.
Not all of them, I think just not. I didn't really know it was
Guys, tonight for homework, you're only doing concept 3A. I have density comms on the board. Ignore those. We won't do the density comms. I will change the website as soon as I can. It won't be until later. Only PS3A. Do not bring your text every day. You use it once in a blue moon. I'll let you know when. Do not steal my important sheet. Don't do it.
Oh, I did.
I saw you.
Oh, were you? That seems like a good combo.
Are you in the group chat? Yeah. Some answers?
Yeah.
I just want to make sure I got everything so you know it's
You won't need it for forever. Leave it at home. I'll tell you when you need it for home for practice, but you don't need it